Okay, so we're going to go over common factoring, okay, and expanding. So we're actually going to start with the expanding stuff. Expanding and simplifying is what they normally call it. And this is a quiz you did. So one of the first questions was you have the number 4 outside of a set of brackets, okay? Now, I'm going to go into some background about this. It's not that important to know, but it's good knowledge to have. Always remember when you're doing math, bed math, okay? And especially because this is technically expanding and simplifying, okay? So technically simplifying is all in there, okay? When simplifying, we always follow this order. We do our brackets first, then our exponents, and then we do division and multiplication technically at the same time, and addition and subtraction. Does that seem familiar to you? Do you remember that? Okay.
Yeah.
So when we take a look at this, this question is to expand and simplify. Okay, well, if I go to simplify this stuff, well, the first thing this tells me to do is look at my brackets. So I look at my brackets, and I have 2 terms inside of the brackets, okay? Now the question is, can I simplify these 2 terms? One of them is an x, and it says plus 5. In other words, are these like terms? Do you know if these are like terms?
They're not like
They're not like terms. That's right. These are not like terms because, well, this guy is a constant, and he's a variable, okay? So in other words, I can't actually simplify what's in the brackets, okay? So then, okay, nothing to do with brackets. Let's go to exponents. Well, I don't have any exponents, so we jump away. Multiplication and division. Well, there's no division. There is multiplication. The multiplication is just 4 outside of the brackets. Now, they haven't written that this is technically multiplied by, but when you have a number beside a bracket, it means to multiply. Okay. So this question says you need to multiply the 4 by both of the terms inside. This is also known as distributive property, if your teacher talks to you about it. Okay. So this is called distributing. Okay. And there's so many different ways of showing this. We're gonna focus on one. Okay. As long as you know one way, you can technically do all of them. Okay. A lot of times they'll call this rainbow method for distributing, and what that means is it kind of looks like a rainbow because we do this number times this, and then this times this. So in other words, what's happening is we're taking the number 4 and we're multiplying it by the x. And then once we've done that, we're taking the number 4 again and we're multiplying it by what looks like positive, okay, positive 5. So the next line is going to read like this. So we have equals. I'm going to write these, we'll color code them, okay? So we'll do the 4 and the x together. So we're doing 4 times x. So I put it together, 4, bracket, x, bracket. And now you know I just said that a bracket beside each other means multiply. So that means 4 times x, okay? And then it's going to be added to
4 times 5.
Exactly. Well, we have 4. And they're both positive, so I'm not putting any sign in front. We just assume numbers are positive if there's no operation in front of them, okay? So this is positive 4 times positive x. Do you know what that's going to give us?
Positive 4 times positive x. 4x.
That's right, positive 4x. Okay, and we're plus positive 4 times positive 5.
20.
Positive 20. So we got 20. So in this case, we get 4x plus 20. I can't simplify this any further because just like inside those brackets we talked about earlier, these are not like terms. This is a constant and this is a variable. Can't combine them, so this is as simple as the question gets. 4x plus 20.
Okay.
Does that one kind of make sense?
Yeah.
Okay, so let's move on to the next one here. Okay, B. Very similar question, but what they've done is they've put a negative into this. Okay, so I'm going to see if you can try to talk me through this a little. What is it I need to do in this question? What is the first step? What would the first step be, you think? And you can refer to what we did up above.
I know there's brackets, there's no exponents, and I have to multiply.
Yeah.
So it'd be 4x.
Yeah, so 4 times x, we know it's going to give us 4x. And what else does 4 have to be multiplied by?
5, right?
Now, it's important that you recognize that this actually is considered a negative 5.
Yeah.
Okay? So, instead of doing that middle step, what is 4 times x?
4x.
Good, you have that. Now, I want you to think about this. This is positive 4 times negative 5. So, do you know what the rules are for positive times negatives?
I'm going to guess, but...
Okay, here, I'll give you a little sheet here. A positive number times a positive number always gives us a positive answer.
Negative times a negative equals positive.
Yeah, a
Well,
negative
that one.
times a negative is still going to be a positive. And then anytime they're not the same, so a negative times a positive or a positive times a negative, you're going to get a negative answer.
Oh, so anytime they're not the same?
Yeah.
Oh, that helps.
Okay, so this one's a positive, this one's a negative. So right away, what type of answer are we going to get? We know.
Negative.
Yeah, so I don't even have to write a number in yet. I just know that it's going to be a negative.
Negative, yeah.
And then what is our 4 times 5?
20.
So
Okay.
our simplified version of this is 4x minus 20. Okay.
And then I'm guessing here I got the sign wrong. It's supposed to be 20.
So let's take a look.
Okay.
Let's take a look at it. Negative 4x times and multiply x minus 5. Okay.
Yeah.
So, like you said before, where do I have to multiply by? What numbers?
The 4 and the x,
Yep.
and then the 4 and the 5.
Okay. Now this is important. Look at the signs in front of them. Okay. This is what type of 4? Positive or negative?
Negative.
It's a negative 4. Okay. So we have negative 4, and this x is positive or negative?
Positive?
Positive, that's right. If
Okay.
there's nothing in front of it, it's assumed it's a positive. So we're talking about a positive times a negative. So right away, my first term is going to have what type of answer?
Positive times negative.
So
Oh,
I already
that
know
matters?
that matters. So I'm going to have a negative to start. So I put the negative in. And what is 4 times x?
4 x.
So our actual first term is negative 4x. Okay. And now take a look at this again. I'm working with a negative 4 times negative 5, right? So a negative times a negative, let's look at our rules. What type of answer are we going to get?
Positive.
Positive. So right away, before I even write a term, I know I have a positive.
20.
So that's where your little error was, is your sign was the wrong one. Okay? And then let's go through D, the only other one we haven't. So we're using the same numbers over and over, just with different symbols or operations in front of them. Okay. I want you to try to tell me this one here. So what do I have to do?
Negative 4 times x.
Yep.
That would be negative 4, because the x is a positive 2. And then, then just 20, right?
It's 20. So then, just like this, is this the answer? Then
No,
missing out?
negative 20.
Why negative?
Because a negative and a positive equals a negative.
Yep, that's right. Good.
Okay.
So you had a negative times a positive, and it's a negative. So is this it? This is our final answer?
Yeah.
Anything missing?
X.
X, that's right, right?
I knew it looked kind of wrong, but could it?
That's right. Negative 4 times x is going to be negative 4x, right? So we've got to make sure we include all the terms. So there we go. We got everything there. That's with multiplication. Now, E on your quiz.
Yeah, only reason I got this right because my teacher let this girl help me because I was just so lost.
Okay. 2m, 7m plus 5 plus 3m squared minus 4m minus 2. Okay. So, a difficult question. Again, we need to think of bed mass. Before we do any types of, this is expanding and simplifying. We're going to talk about bed mass. Okay. Do I have any brackets?
No.
Nothing to do there. Do I have exponents?
Yes.
I do have exponents. Can I do anything with these exponents? This is 2 times m squared. Can I square m? Do I know what that number is? No, so I can't really do anything with that. Okay? Same with the one over here. This is an m squared. Well, I don't know what the value of m is. It's some number. That's what m stands for, some unknown number. So I can't square it because I don't really know what it is. So there are exponents, but I can't do anything with them. So my exponents are gone.
But sometimes don't you have to divide or add them?
We're going to get to that, right?
Okay.
But we're talking about the general idea first.
Okay.
What about division? Anything to do division in here?
No.
No. Any multiplication you see? No, there's no multiplication. So the last two, and they go in order from left to right, is adding and subtracting. Okay? Now, the problem here is you can only add and subtract like terms.
Yeah.
So we have to figure out what is a like term and what isn't a like term.
The
So
3m and the 2m.
that's right. Now this 2m is what? Considered positive or negative?
Positive.
It's technically a positive. And this 3m is what? Positive or negative? Good. So I'm underlining those in red. Okay. What else is a like term?
Negative 7m and negative 4m.
Negative 4m. Good. Any other like terms?
And then the 5. Oh no. No other like terms.
That's it. What about that 2? Does it belong to anything?
Oh, it's a negative. No, they're not the same because that's a negative 2 and that's a positive 2. I mean 5.
Well, we had over here. Let's think about this. Oh shoot, they're all the same in this case. Technically, it's not the sign in front of them. It's if there's a variable attached to them. Okay? So in this case, the variable m squared allowed these two to go together. It didn't matter that they were positive or negative operations. Just like this one was just m, it allowed the two m's to go together. And this one, think of it, now this m is technically to the power of 1. Have you guys ever learned that before?
Yeah.
Cool. Here's a little trick. Technically, these constants, this could be m to the power of 0. Okay? We don't write that in. It's actually kind of confusing. But that would give them a like term idea. Okay? So we don't write those in. So it's just constant terms.
They fade away.
Yeah, that one fades away.
Oh.
And the constant terms, they are like terms. Okay? If they're just the number itself. So let's reorder this, okay? So we can make some sense of it. And we'll color code it. So we have 2m squared plus 3m squared. We know those are like terms. I had negative 7m minus 4m. And we had positive 5 minus 2. Okay? So now what we're going to try to do is we're going to try to collect this. Now this is adding and subtracting integers. This can be confusing, but let's try to work through this. Our very first one, this is 2m squared plus 3m squared. How do I add those numbers?
Does the exponents matter?
No, in fact, the variables and the exponents, because we're adding and subtracting, they don't change at all.
Okay.
It's the coefficient that's important, it's called. Do you know which one the coefficient is?
The number.
The number, yes. So we actually just focus on this number here.
So it'd be 5.
That's it. That'd be 5. So what would the whole term be? 5?
5m squared.
Perfect. Okay. Now, we've done that. We've combined those two terms. Now let's go to our next two like terms. Now, again, we focus on the coefficients. This one's a little trickier. This is negative 7 minus 4. Okay. Do you know how to do those two integers?
I'm guessing it's negative 3m.
You're definitely right with the m. Okay. And it is going to be a negative, but I want you to think of a number line. Now, I know you guys probably haven't done integers in a while. But on a number line, think of it like this. We've started at the term negative 7. So I'm at negative 7. And it's telling me to go in a negative direction 4. If I go back 4, 1, so this gets me at negative 8, 2, negative 9,
Negative
3.
11.
Yes.
But how do I know when to do that? I always get confused.
Always start at whatever the first term is. So the first term was negative 7, so we started there. And then look at what the operation is. If it said plus 4, we'd go in a positive direction. And it said negative 4, so we went in a negative direction. So we started at negative 7 and we went backwards 4. Okay? So our term will actually be negative 11m. Okay? And then finally, same idea. Let's do another number line so we can try to make sense of this. What term do we start at?
5.
Alright, so we start at 5. I'm at the number 5, and it tells me to go which direction?
Negative this way.
So what's 1 before 5?
4.
4, and then another one?
3.
Which makes sense, right? 5 minus 2 is 3. So plus 3. Now I'm just going to write it in black so it seems like a permanent answer.
Okay.
5m squared minus 11m plus 3. Okay. So that's everything we've done so far. That's up to E. Okay? We're going to jump over to F now. I'm just going to move to another page so we have some room. Okay, so this one, question F states, let's get the page with me. X squared plus 3x.
Plus 1. Negative 2x squared. Negative x. And then negative 1.
Good. All right. What's the rules we have to follow? What's that acronym?
Bed mass.
Bed mass. So let's talk about it. Any brackets?
Mm-mm.
Any exponents?
Yes.
Right? Let's look at them carefully. Can we do anything with them? This is an exponent of a variable. Exponent of a variable. Do I know what that x is? I can't simplify it then, right? So there's nothing we can do with those exponents. So we can't do anything with those two exponents, okay? So no more exponents. Any division? Any multiplication?
No.
So adding and subtracting, and we're going to have to collect our like terms again. So tell me, what are like terms here?
Would the x squared and the 2x squared be like terms?
Yep. And now, is it just 2x squared, or is it?
Negative 2x.
Yes, that's important. Always
But
make
that
sure
one-
the
but
signs
then
there.
this one, the one on the left hand side, doesn't have a constant.
Ah,
Inverse constant.
if there's nothing there, what
Oh, it's
do?
1.
That's right.
Oh, yes. Okay. Okay.
So we assume it's the number 1 is
Okay.
there. Okay.
Mhm.
What's another set of like terms?
Positive 3 and negative 1.
Good. Now, is that the one you
Wait.
went, or did you mean this one?
Yeah. Oh, yeah. Yeah. This one.
You mean this one over here? Oops, that one's way too big. I erased the entire number. What was that number again? Minus x, right?
Yeah.
So you're saying in the negative 1. Now,
Yeah.
why would these be like terms? Do they have the same variable at the end?
No.
Can they be like terms then?
No.
No, they cannot be.
So then we say positive 1 and negative 1.
Okay, so you're right. Positive 1 and negative 1 are definitely like terms. Let's get those up. We'll do that in green. Positive 1 and negative 1 are like terms. What about this 3x? Does it have a like term?
The negative x
And what's the...
becomes 1.
Yes, so it's negative 1x. Okay, so I've drawn those numbers in there so we know that those coefficients are 1. So let's work on this now. I'm going to reorder my question. We'll do this stuff in red. So what were my red like terms?
1x squared and negative 2x squared.
Good. What were the blue ones?
Positive 3x and negative 1x.
Good. And the green ones?
And then 1 and then negative 1.
Good. So we're going to focus on combining each of them. Okay. So when we combine each of them, let's talk about the very first set. Again, let's think of our number lines, okay?
Mm-hmm.
So what's the first term? The number
1x
what?
squared.
Okay. So let's look at just the coefficients. Remember, when we do those, we only look at the coefficients. So I'm going to underline all the coefficients and the constant numbers. So we know that the x's we're going to keep the same. We just got to focus on the numbers in front. So what is the first coefficient? What's that first term?
1.
1. So I start at the number 1. And what direction does it tell me to go?
Because positive we go this way. Right?
Okay, what's the next term?
Oh, sorry.
We started at
then-
positive 1.
Negative 2.
So that means we go which direction?
This way.
Yeah, we go to the left or negative 2. So what would come before positive 1?
0.
0. And then that's 1.
And then negative 1.
So what is the term?
Negative 1.
Negative 1.
X squared.
Yeah. We got to put those in, right? We can't forget about those.
Okay.
Good. So you got that part. Let's do another number line. Our integers are actually really important when we go through this, okay? What's our first blue term here?
Positive
So say we start at positive 3. Which direction does it tell us to go?
3. Left.
Yep. So what will we go to?
2.
That's right. So what is this when we combine them? We're going to get...
Minus positive 2.
Do we have to minus? What number is this here?
Plus.
Plus.
2.
So we say plus. Because it's positive, we say plus 2 what?
2.
Anything else we have to include in that, or is it done?
Is it done?
Did we leave anything out? What about in this one? We included the x squared.
Oh, I keep forgetting the x. Sorry.
Yeah, that's okay. So we got to work with the x now, right? We got to put that in also. So plus 2x. And then finally, number line again, just to make sure. Where do we start? What term?
Positive 1.
So I'm at positive 1. Which direction does it tell me to go?
Left 1. So 0.
0. So I can just put plus 0. Now, do I need to write that plus 0 in?
No.
No. So let's actually write out what our answer is in black here. Negative. Now, do I need to include this 1?
No.
I don't. It's not wrong if I do. Okay, so just know that both of these would be right, but I'm going to leave out things I didn't have to write. So I can just write negative x squared because we assume the 1's there. If you wrote the 1, definitely not wrong. Don't worry about it. And if that's the best way for you to remember, write that 1 in. Okay? Plus 2x, and I don't need to write the 0. If you wrote plus 0, that's fine. It's not wrong. It's just this is a simpler way of doing it. So our answer would be negative x squared plus 2x. Okay, so we're expanding and simplifying again. Now, you did a very good job at this one. You knew right away, okay, I need to multiply my coefficients together because this is a multiplication question. The one thing you did leave out, though, and we'll do that first, what is 9 times negative 3? You had the right answer.
Negative 27.
That's right. Now, what you did, I'm going to do these in blue, the x's. Now, when we add, and we're going to refer back to that other page we just went through. Oops. Okay, when we add, you're right, those variables stay the same as they were. But because we're multiplying this question, it changes it a little. Okay? And what I'm going to do is I'm going to add an extra step in the middle, and then we're going to kind of drop it off at the end there just so it kind of makes sense here. So, I'm going to move this down. And we're just going to write out exactly what you're doing. So the very first thing you did is you multiplied 9 times negative 3, which is right, because it is multiplication. And technically, I know they don't even talk much about that. This says 9 times x. And this technically says negative 3 times x. So, I'm going to draw some extra steps. Don't let them confuse you. And if you don't like them, you don't have to remember them. But they're just to help to make sense of exactly what we are doing here. What this question really says is 9 times x times negative 3 times x. There's actually 4 terms we're multiplying here. Okay? They've just kind of combined 2 of them and then set them together. What we're going to do is we're going to reorder them. I'm going to multiply my coefficients by each other, and I'm going to multiply my x's by each other. So that was 9 times negative 3 and x times x. Now you did this properly. 9 times negative 3 is 27. X times x. This is multiplying exponents. Now technically this is x to the power of 1 times x to the power of 1. But when we multiply bases or powers that are the same, we keep the base the same, and it'll be x, and we add the exponents. So it's 1 plus 1, yeah, x squared. In other words, there's 2 x's, which we knew that, right? So here's a little rule to it. So in other words, it would have been negative 27 x squared. Now, you definitely do not need to do the amount of steps I did here, where I did this one, and this one, and this one, and this one. After a bit of practice, you're going to go from here right to here very quickly, okay? But that's technically everything we do. We just do a lot of it in our minds, okay? So let's talk about question G. Or not G, sorry, H. Question H says 4a squared multiplied by negative 7.
Oh, it's supposed to be 3. How am I guessing?
Yes. No, you're 100% right. So walk me through this. Tell me how I complete this question.
You make it so confusing. Okay, Okay. 4 times negative 7.
So we do 4. I'm going to write it in red. 4 times negative 7.
Equals.
Okay. Equals.
Positive negative, right? So negative 28.
Yep. And then
the a squared right there means 2 a's. And then the a squared right there has a 1.
Yep.
So add the exponents. A3, is that how you say it?
It's a to the power of 3.
Oh, yeah.
A squared.
Come on.
A to 1.
Okay, a to the power of 3.
So a to the power of 3. So what's our answer down here?
Negative 28 to the power, a to the power of 3.
Yeah. So it's negative 28 a to the power of 3. So your exponent was off in that question.
Okay.
Now that's with multiplication. Okay, so we've done 2 multiplications here. Let's take a quick look at these pages. Okay, we can keep going. HI. Okay, I is a little different because it's a division question. So 25 x to the power of 4 divided by negative 5 x to the power of 2. Now, oh, you got this question. Now I want to make sure you understand what you did in this question, okay? The other two were multiplication. So like we said, we got our like terms and we multiplied them. In this one, we're going to kind of take our like terms and divide the two.
Oh, I think I subtracted it.
And that's exactly what you have to do. So the very first one, we have our 25 and negative 5. What is 25 divided by negative 5? So the rules... Yep.
5.
Negative 5, that's right. The rules for multiplying positives and negatives are the same for division. Yeah. So you're right, it's negative 5. And what you do here is, again, our exponents, right? Well, when we're dividing them, when it's divided by, or in refraction form, either one's the same, we take the base and we subtract the two exponents. So this will end up becoming x to the power of 2, which is exactly what you wrote. Your answer was negative 5x squared. Okay. So let's see if you can walk me through question J then, thinking about those rules. Negative 42x squared divided by...
Wait, why is that wrong?
Negative 6. I'm going to show you why. X squared. What's the first things we focus on?
The negative 42 and the negative 6?
Yeah. What are you going to get? It's a negative and a negative, so we'll get a...
Positive?
Yep. 42 divided 6. So you just calculate?
Yeah. 42 divided by 6. Oh, so I knew it. Okay, 7.
Yep. Now, let's set this up. They're divided by, right? So what does that mean we do to the exponents? We
subtract them.
So 2 subtract 2 gives you what?
0, so just x.
No. X to the power of 0 is a specific number. X, anything to the power of 0, anything at all. Okay, so I'll do this in a minute. Let's say I had 15 to the power of 0. 8 to the power of 0. That really looks like a 6. That should be a 0. X to the power of 0. 10 billion to the power of 0. And Z, Y to the power of 0. They're all going to give us the exact same answer. That answer is 1. Any number to the power of 0 is 1. So what is 10,000 to the power of 0?
Why call it to the power of 0?
It's saying there's no exponent, so it takes it to its most basic base, is what it's trying to say. So the number 1 is the most basic base. So x to the power of 0 is 1. Okay, so we're going to actually write that in. And remember we said this is technically multiplication between these two guys? Mm-hmm. So he's kind of like 7 times 1. What is 7 times 1?
7.
That's your answer. Just the number 7.
So no x, no nothing?
No nothing. Just the number 7 is your answer. Okay, so we're going to go over common factoring. They've given us this expression, 5x plus 35. And they're telling us to find the greatest common factor. Now, factoring is the opposite of what we've just been doing. We've been expanding, and what we've been expanding is we get things like this. We get some number and a bracket, some number plus some number bracket, and then we end up with, two terms. That's what we were doing before, right? That was the general idea. We're doing the opposite. We're starting here, and we're going back to with the brackets. Okay, that's what we're trying to do. Now, in order to do this, I have to find common factors. Okay. Now, when I'm looking for common factors, I'm going to look for the coefficients first. Okay. Now, the coefficients in these are 5 and 35. Now, I might ask you right away, do you know what the greatest common factor between 5 and 35 is? Some people might be able to tell you right away, yes, this is it. Some won't. So if you don't, this is how we set this up. We write out the number 5, and we write out the number 35, and we write all their factors out.
Oh.
So factors of 5. Remember doing this in elementary school?
Yeah, I hated this.
Yeah, one end, 5. Luckily, 5 is considered a prime number. Those are the only factors. 35 has a couple more. 1, 2 doesn't go in, 3 doesn't go in, 4 doesn't go in, 5 goes in, and it's technically 5 times 7, and then 1 and 35. Okay, so those are all the factors of 35. Well, we look for the greatest common factor. Now, there is a common factor, 1, and 1 will be a common factor between any number. Everybody's going to have that. But this also has 5. So in this one, 5 is our greatest common factor. And the more you do this, the more you'll be able to notice that. So what that means is I'm actually going to divide each of these terms by the number 5. Okay? Yeah. So when we do that, now this 5 doesn't disappear. It's very important. He comes outside, kind of like in this spot here. And then we write our brackets in. And that's where we're going to get these two terms now, is by dividing those. So we divide 5x divided by 5. Well, what's 5 divided by 5? Do you know?
5 divided by 5. So that's 0, right?
Not 0, but 1.
1.
It's 1 in this case. So our number is 1. I'm going to write it in. Technically, it's 1, and then the x stays, so it's 1x. And 35 divided by 5, or positive, sorry, I should have said that. Positive 35 divided by positive 5. Still a positive term.
Positive 7.
So, that's right. So that's how we got this first term in this bracket and this second term in the bracket. We divided from above, okay? We divide and we brought them down. So this is actually it. This is our final answer. Our final answer is 5. We don't have to write the 1 in. X plus 7. But this was the form we were working with before. Okay? And what we were doing before is we were taking this form and putting it into standard. Okay? Now it's in now we're putting it into factored form. That's what the two differences are. Okay? So I'm going to call them like this. I'm going to give them two different names. Okay? So we have this one here. I'm going to say y equals. That's what most things are written as. Have you seen that before? Y equals, and I'm just going to put letters in front right now. Okay? Y equals a x plus, we'll call it the term c. Okay, just because eventually this will make sense. This is called standard. Okay. And in this one, we had y is equal to a bracket x, and we're just going to make up a letter here. We'll call it r, okay? And this form is called factored. Okay? So, and we're going to talk about moving between the two of them. This is what's important. Because you have to realize that these are actually related to each other. I know we've done a lot of math today. So, trying to get this touched on. Let's talk about how to move between them. To go from standard to factored form is exactly what we're doing right now. It's called factoring. To go from factored to standard form, it's what you did on your quiz. It's called expanding. So we're moving between two forms of the same equation. The equations haven't changed at all. The equations are still the same. It's just we put one in factored form or one in standard form. Okay? So everything you did on your quiz was moving from factored to standard. And everything we're doing right now is moving from standard to factored. So we're factoring. Okay? So let's do another quick example here. Another example we could use. 10x minus 15. Great. So, let's take a look at this. 10x minus 15. I need common factors. So, between 10 and 5, do you know what the greatest common factor would be?
5.
5, that's right. Good. We're already starting to see them. So I'm going to do what to each term?
Divide them by 5.
Divide each by 5. Where does that 5 go?
Outside the bracket.
That's right. So we have 5 outside of the bracket. And what's left inside the brackets?
Those two terms.
Okay. What is 10x divided by 5?
Oh, 2. 2x.
2x, yep.
Oh.
And what's negative 15 divided by 5? So that's it. That's our final answer. Again, I just write things in black. There's no change. It's just so it looks like a permanent answer. And that's it. We've gone from our standard form to our factored form. Okay?
So I have to divide, like if I had an x function, I just have to divide, find the greatest common factor, then divide it by it, and then put the greatest common factor on the outside.
Yep. Now, here's a more difficult type question. Okay? X squared plus 9x. This one's a little more difficult. We look at the coefficients first, and we're going to divide them. Do you know what the greatest common factor between 3 and 9 is?
Greatest, right?
Yeah.
18?
Well, remember, it's factors, not multiples. So let's...
3.
Yeah, that's right. 3. Now, this question's a little different from the other two because I actually have a variable on both. And it's the same variable. It's the letter x. So what we do in this case, and I'm going to write it out for you so it makes a bit of sense, because we just take the variable with the lowest exponent. What's the lowest exponent on these two variables?
The lowest.
So this one has the exponent of what?
2.
And this one has the exponent of?
And that'll be 1.
So I just take the one with the lowest exponent, so I take the x squared. So I x to the power of 1. And I don't need to write the 1 in. So I'm actually, this is the greatest common factor, 3x. And I'll explain that. The reason we take that is because if I write the factors of x squared, well, they're just actually x times x. And the factors of x are just x. So the common factor would be taking out 1x of each of these. So that's what we did here. We took out x to the power of 1 for each. Had it been different, and we'll do one quickly at the end, where it is different, we would have taken more x's out. So this 3x, it now goes where?
To yes.
Outside the brackets, right?
Outside the brackets.
So we have our 3x. Now here's a little more difficult part. That's why we need to know that stuff. 3x squared divided by 3x is going to give us what?
3x?
Well, the 3 divided by 3 is what?
0.
0.
1.
1, yeah. So we have 1. X squared divided by x to the power of 1.
X1.
X1. 9 divided by 3?
2. No. Oh, 3.
That's okay. This is the one you got confused on last time. X divided by x. So it's technically power of 1 divided by power of 1.
So you just leave it. The x doesn't go.
What they usually say is they say it cancels out. It technically creates a 1. Remember we said it because what happens is we're going to get x to the power of 0, which is 1. Right? It creates a 1, but the 1's not important because 1 times 3 is 3. So this is it. This is our final answer. It's instead of just a coefficient, there's a variable this time. 3x, and then we have x plus 3. The last example we'll go through, and that should be enough for today. I'll make up one more. Okay. Okay. I need to take the greatest common factor from both of these. Do you know what it could be?
Greatest common factor.
Just the coefficients.
12. I mean, that's a multiple.
Yep, good.
So, 2.
That's right. 2 is it for both coefficients. Now, this is the tough part. The x's. If I have x cubed, how many x's do I have? Or x to the power of 3, how many are there?
3.
2, 3. If I have x squared, how many are there?
2.
So how many can I take out?
4.
1, 2. Let's think of pairing, sorry. How many pairs can I take out?
2.
I can take out 2 pairs. So in other words, I now write it as x to the power of 2. Or like we said before, remember I told you it's a shortcut? Just look for the variable with the lowest exponent. This one's a 3, well this one's a 2, so we take out x to the power of 2. That's how we know how to do the variable. I know that idea is a little tough. Let's keep going and finish this one. So that 2x squared, where does it go? At the bottom that we divided by?
Oh, on the outside of the bracket.
Yep, 2x squared. What's left inside?
4x and then negative 6.
Is it 4? What's 4 divided by 2?
2.
So 2x, yep. And then
Negative 3x.
is there an x involved?
No,
Why not?
because it's x squared and x squared, so they can't be.
Great. So that's it. That's our final answer there. So we went over a lot today. We went over 2 lessons, expanding and simplifying and factoring.